Come. नमस्कारम, वेलकम, वरकम, सुस्वागतम. जो बोले सो निहाल, सत श्री अकाल, वालेकुम सलाम, अस्सलाम वालेकुम. Kids, do let me know in the chat section that can you hear me, can you see me? I want to see green signal. So today we are going to start with very important topic that is known as the backbone of chemistry, organic chemistry. First of all, if everyone is your Baba completely audible as well as visible, if yes, I want to see some fire in the chat section. Kids, this is all your love and support that Baba is over here. Kids, on this 15th of August, when everyone is busy in just making this festival a grand festival, kids, we are celebrating with resonance, the backbone of organic chemistry, which holds a hell lot of weightage, kids. Now I want to see, yes, ultimately the team effort, the backend team was continuously working very hard to make it successful. Oh my God, all my dear students. एक बार हिंदी में प्रिंस शर्मा जी, वाओ प्रिंस इज देयर. जो बोले सो निहाल, सत श्री अकाल, गुड इवनिंग, नमस्ते, खंबा खानी, या. Kids, I will start from the scratch. This is for each and everyone. If you are in class 11th, अगर आप class 11th में हैं, then this is for you. 12th students, this is for you, because if you are going to start your hello LKs, hello LEs, my dear students, right now here is power cut. You can see the sweat. Too much sweat is here. Power cut is over here. The class is going to run on internet, kids. Internet connectivity is from the inverter. So inverter is going to give us support. Everyone, wow, Aman Jha is there, Sahana is there. I can see everyone, kids. Wow. So are you ready? Radhe. Very simple English. But before I start, kids, let me tell you, help everyone. You know, kids, number of students are here in our India, or I can say out of India, those who are not having that much of money. If they are having money and they have taken offline admission, but they are not getting good teachers, kids, you can help them by sharing. Sharing is caring. If you are sharing these things, then Almighty God is going to help you a lot, kids. So this freedom to learn, freedom to get succeed, lowest ever price on all NEET UG subscription. It is just available for 4,999 kids. Very low price. Let me write down this: 4,999. Less than 5,000, almost 5,000. You can say you have to apply code HSP 10. Tell them to apply code HSP 10, kids. This code, if they are going to apply, they will get mentorship. Baba HSP's mentorship along with huge discount, kids. Right? So let's start the class. Oh my God, Sahana, thank you. Thanks a lot. Now, kids, Baba is going to start with the resonance. Hey, resonance. Baba is going to start with resonance. Resonance, the backbone of organic chemistry, kids. Backbone. I would like to say backbone of organic chemistry. Now, my dear students, whatever you study in your organic chemistry, this is necessary. I will start from the scratch. We will do number of questions, but before I start, let me show you electron. If you are unable to see, if you are unable to visualize electron, you won't be able to understand resonance. So just to get the feel of resonance, you should know how electron looks like. Kids, see, we haven't seen electron, no one has seen electron, but we should have to keep this electron in our brain. So see, Baba is going to draw the electron. Electron is having particle as well as wavical nature, means particle as well as wave. So particle plus wave, this is wavical. These two are hands, these two are legs. Now why I have drawn like this, kids? If electron wants to move, it will require orbital. Just see, two hands will move from this one lobe and two legs will move from this one lobe. One lobe for hands, one lobe for legs. This is imagination. This is your Baba's imagination. If you are able to understand this, you will ultimately understand your resonance, kids. This is my imagination. This will be known as pure p orbital. What, kids? Pure p orbital. That means, and this is free electron, not the bonded one, free electron. So I would like to say only one thing. There should be free electron and there should be pure p orbital, then resonance is possible. Only two things are required, free electron and p orbital. For resonance, only two things are required, pure p orbital and free electron. How many of you got it? Now, kids, see what I am telling you. What are free electrons? Free electrons means, your free electrons means pi electrons. Now pi electrons can be of lone pair or they can be of negative charge or lone pair. These are the pi electron free electrons. Now what is your pure p orbital? Let me tell you pure p orbital. Pure p orbital is anything which is being carbocation, kids. Carbocation will always have pure p orbital. Boron will have always pure p orbital. All pi bonds, because pi bonds are not hybridized. So that means they are also pure p orbital. Is it clear, kids? So these are pure p orbital. Now see how the resonance will take place, kids. Let me tell you resonance, how it is going to take place. Now if I say any double bond X double bond Y Z, now see, this is the pi bond. Pi bond means pure p orbital. Pi bond means what? Pure p orbital. And my dear students, if this Z is having either double bond, or Z is having negative charge, or Z is having lone pair, or Z is having free radical, or Z is having positive charge, any of these 5 things, any of these 5 things, they will be responsible for mesomeric effect. What I am telling you, kids, they will be responsible for mesomeric effect. Are you getting my point, kids? Mesomeric effect. Kids, everyone, are you able to see me? Let me check it out. Just refresh. Let me refresh whether everyone is able to see me, watch me. Kids, hit the like button if you are able to see me, if you can hear me, everyone. Kids, now see, if Z is attached with double bond, or Z is attached with negative charge, or Z is having lone pair, or Z is free radical, or Z is having positive charge, in all these cases, resonance is possible, kids. Resonance will be possible if any of these things are possible, kids. Now see how the resonance will take place. I will say the first one is double bond conjugation. Double bond conjugation. This is double bond negative charge conjugation. This is known as double bond lone pair conjugation, and this is double bond free radical conjugation, and this is double bond positive charge conjugation. So these are the 5 types of mesomeric effect, kids. These are the 5 types of mesomeric effect, kids. These are known as 5 types of mesomeric effect, kids. Mesomeric effect. Now let me explain one by one. Let me explain all these one by one. Are you ready? First mesomeric effect is double bond conjugation. Double bond conjugation. That means pi bond conjugation. Suppose if I write CH2 double bond CH, double bond CH2. Now you can see this pi electron can move from this place to this place, and this pi bond will move from this place to this place. Displacement of electron, my dear students. Categorically I am telling you, displacement of electron. So this is loser, this is going to lose, it will develop positive charge, this will develop negative charge, this will develop positive charge, and this will develop negative charge, kids. Now in between these two, bonding can take place. Negative charge and positive charge, pi bond formation can take place. So you can say CH2 plus CH double bond CH, CH2 negative. These two are resonating structures, A and B. These two are resonating structures. Are you getting my point, kids? Now this moving electron is going to create this resonating structure, and that means if electron is moving, from one atom to another atom, from one atom to another atom, kids, this we can say, either we can say delocalization, or we can say resonance, or we can say mesomeric effect. And remember that the pi bond and pi bond, these two pi bonds, their energy is almost same. This pi bond, their energy is same. So pi bond conjugation is the best conjugation, kids. Are you getting my point? This pi conjugation is the best conjugation because their energy is almost same. So this is the best conjugation, So I'm going to give you one more example of it. See, the well-known example is your this compound. Could you please help me? What is this? What will you say? This compound is what? Everyone who is watching, kids, do let me know. This compound is what? Write down in the chat section. Write down in the chat section what is this. Everyone will say this is benzene, but I would like to say it's not benzene because it is resonating structure of benzene. It is resonating structure of benzene. It is resonating structure of benzene. It's not benzene, kids. Let me tell you clearly, it's not benzene at all. It is the resonating structure of benzene. Why, kids? Why, kids? Because this only compound cannot explain each and every property of benzene. Why? Why, kids? We know that carbon, 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 single bond length is 1.54 angstrom, and carbon double bond carbon bond length is how much, kids? 1.34 angstrom. But if this is single bond, this is double bond, then double bonds bond length is expected to be this one, and single bonds bond length is expected to be this one. But in benzene, my dear students, in benzene, my dear students, all carbon-carbon bond lengths were found to be 1.39 angstrom. All they were found to be 1.39 angstrom, kids. This means, my dear student, this means that only this structure cannot satisfy each and every property of benzene, kids. That means we need one more structure like this. See, kids, if this pi bond is moving like this, then this pi bond will come over here and this pi bond will come over here, and its resonating structure will be like this. So this is first, this is second, and these two are the resonating structures, canonical structures of benzene. They are not actually benzene, kids. They are not benzene. If I talk about the fan, you see fan, once it is moving, then the probability of finding electron is everywhere. Just like if I say the hero is having that talwar sword, and its sword is moving at 360 degree like this, then the probability of finding that sword will be everywhere. For example, my hand, one hand is there and someone wants to throw some bullet or some stone on me, and if I rotate my hand like this, now see, this one hand is looking like number of hands. Just see, this is not only one hand, it's looking like that number of, this is doing resonance. And when somebody is doing resonance, the probability of finding that bond is everywhere, everywhere. Just see, kids. Kids, just see. So these two are canonical or resonating structures, canonical or resonating structures, but they are not benzene. They are helping in defining the properties of benzene, but they are not actually benzene, kids. You are getting it? So I can say this is the resonance hybrid, and actually benzene is like this. So the electrons, they are moving, and due to delocalization of pi electrons, the energy got decreased. This compound's expected energy was 86 kilocalorie per mole. But experimentally it was found only 50 kilocalorie per mole. Now, the expected energy was 86 kilocalorie per mole, but it was experimentally found just 50 kilocalorie per mole. How much energy is less? How much is the difference? Difference is of 36 kilocalorie per mole, and that's why, my dear students, let me tell you, this benzene got stabilized. Why the benzene got stabilized, kids? Who is responsible for stabilizing benzene? That means the pi electrons can move. How they will move? See, kids. Here is one pi electron, 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 here is one pi, here is one pi. So the all pi electrons are moving above the plane, below the plane, moving 8. In each and every carbon, they are moving like this, up and down, and they are making 8. And they are moving like this also over the whole entire area. And you know that if you have got freedom, and today's Freedom Day, I would like to say, kids, on this Freedom Day, that we want what? Freedom. Thermodynamics says entropy is degree of freedom. We want freedoms, and definitely wavical electron that needs freedom. And if the electron is moving like this, see, kids, above the ring like this and below the ring like this, so it has got freedom, and due to freedom, its energy got decreased and its stability got increased. Kids, are you getting my point? That's why this benzene is always drawn like this, kids. This benzene is always drawn like this. The pi electron clouds above the plane and the pi electron clouds below the plane. Benzene is always drawn like this. Pi electron clouds above the plane and below the plane, and that's why benzene is said to be. Benzene is stabilized by how much, kids? How much? Stabilized by 86 and 50. That means minus 36 is delta H. Change in enthalpy is always negative, and this is resonance energy, and that means it is stabilized by 36 kilocalorie per mole. I hope everyone got it, kids. Everyone is able to understand this much. If yes, show me some green hearts, some fire in the chat section. Kids, do let me know. Always resonance energy is exothermic, and we will say it is stabilized by 36 kilocalorie per mole. Kids, today is 15th of August, that needs independence, and here also we are talking about the freedom, kids. We are talking about the freedom. Just a second, kids. Kids, wow, everyone, you are getting it. Everyone, you are able to understand. Now see, kids. Second type. Let me tell you the second type. Are you ready for second type of mesomeric effect? If you got this one, second type, that is negative charge, pi bond conjugation. Now see, kids, if I say that I have got compound like this, CH2, double bond CH, CH2 negative. Now many students must be waiting for questions. I will give you questions, but once the fundamental thing is clear, kids, once the fundamental thing is clear, I will give you each and everything. Most of the students, they think like organic chemistry pedicare customer, but I would like to say it's romba sulbham. In the starting, each and everything will look like idiyappam muruku, but Baba will make it nalla iruku, romba sulbham. Then you will say arpudham. Kids, everyone, are you ready? Now see, who is more free? This pi electron, the green pi electron is more free, or the orange pi electron is more free? Remember that the one who is having negative charge. The atom who is having negative charge, that means having extra electron, and the one who is having extra electron indicates what? Extra electron means, yes, one extra electron, Z effective will be less. Z effective will be less. Z effective will be less. And Z effective is less, that means more free. So remember that from which side to which side electron will flow. Remember that my point 2 we noted, my lord, point 2 we noted, my lord, that electron will flow from this to this. Always remember that negative charge to pi bond. Flow of electron will be, from negative charge towards double bond. Now see kids, what are the consequences you are going to see of it? Just see how will you do all the questions if you are able to understand this thing. See kids, let me tell you what you will see the consequence. Just see kids, if I give you one compound like this, you know that this benzene is electron rich. This benzene is electron rich. It is already having 6 pi electrons. 1, randa, mono, nale, anche, are 6 pi electrons. Benzene is electron rich. Now my dear students, once a benzene is electron rich, you know that this carbon will donate electron to the benzene or will withdraw electron. Just to let me know. The carbon which is having negative charge is going to donate electron to the benzene or is liking to withdraw electron, because this is going to change each and everything. Kids, do let me know. So definitely it is having negative charge. So the flow of electron will be like this. It will come to this carbon and this is going to lose to this carbon. Am I right, kids? If you are able to understand this much, this is going to change your future, kids. Now definitely it will look like this, kids. So it will get double bond and here you are going to get negative charge. Now the electron will say, oh, now I know how to move. Now electron will say, now I know how to move. Now electron has learned how to move, how to do resonance. Now electron has learned how to move, kids. Now it will not wait. It will say, oh, let's move, yeah. Let's move, yeah. I want to come over here. Just you go over there. The thing is happening in between 3 atoms, and whenever the thing is happening in between 3 atoms, remember that we will say mesomeric effect, and the carbon is losing electron, and the one who is losing electron will get little bit electron deficient. So I will say this group is plus M or plus R. Whenever I am talking plus M plus R, remember that either plus M or plus R, that means electron donating group, EDG. Remember that, EDG, electron donating group. It is donating through plus I, it is donating through plus M, it is donating through plus R, RMI. It is an overall electron donor. Through plus I also it is donating electron to the benzene. Through plus M also it is donating electron to the benzene. That means overall it is donating electron to the benzene ring. And mainly remember that it is donating through resonance. The negative charge will come over here. And now the situation will look like this. See kids, it will look like this. First, the negative charge has come on ortho. Now the negative charge has come on para, and now once again the electron will move. Just move, yeah, just move, yeah. It will move and it will look like this. Kids, it will look like this. Now once again it will go back. The electron will go back, and the whole phenomena will be known as what? The whole phenomenon will be known as resonance. Resonance. How many resonating structures it has formed? By the moving of electron, it has created how many resonating structures? 5. What? Voice is not clear? Nagapani is saying voice is not clear. Everyone, kids, do let me know. Only one student is writing voice is not clear. Rest of the other students, just do let me know. Am I properly audible and visible to each and everyone, kids? I think either one student is not able to hear me, or it can be the spam. Just do let me know. किरण पाठक जी, क्या आप मुझे सुन पा रहे हैं, देख पा रहे हैं? रेस्ट ऑफ अदर स्टूडेंट्स, सहाना, इट्स परफेक्ट. दैट मीन्स that student is either doing spamming, spammer is there, he is spammer, or refresh your system. Refresh your system. Now the one structure which is going to explain all these properties, that will be known as the true structure, and I am going to draw the true structure. See, partial negative, partial negative, partial negative, and the electron was moving from here to here, and there was also single bond got partial negative charge, and this is like this. This is the true structure, kids. This is your true structure. I hope you got it. And this is known as resonance hybrid. Resonance hybrid, kids. It is known as resonance hybrid, and this is going to explain each and every property, kids. Let me tell you that this is the single structure, and the single structure is going to explain all the properties. This group has increased electron density at ortho and para, and so I will say the coming electrophile, if any time electrophile is going to attack on this benzene, this is rich benzene, and this is electron deficient. This electron deficient will attack on which position? Ortho, para, meta. Tell me, it is going to attack at ortho. Ding ding ding. Ding 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 ding. It will attack on para. So this is known as ortho para director, OP director, because it will allow the incoming electrophile at ortho para position. So we will say it is ortho para director. Is it clear, kids? It is useful for JEE Advanced. Every NEET students, any examination you are going to prepare, this is equally important, kids. Let me tell you, this class is for each and everyone. JEE Advanced, NEET, if you want to get the best rank, then also, kids. Okay, kids, this much is clear. Now Baba is going to explain the third one. Just see the third one. Third one, are you ready, kids? Are you ready for that? Third one is lone pair pi bond conjugation. Again and again I am using one word, that mesomeric effect and resonance. Remember that, my dear students. Mesomeric effect is like, if I say mesomeric effect is like Punjabis. Mesomeric effect is like, if I say mesomeric effect is like Punjabis. Punjabis, the Punjab people. And if I say resonance, resonance is like Indian. Resonance is like what? Resonance is like Indian. So can I say, kids, all Punjabis are always Indian? All Punjabis are always Indian? Always. But all Indians need not to be Punjabis. But all Indians are not Punjabis, because some of them are Tamilian, some of them are, Maharashtrian. Are you getting my point? So resonance is a bigger thing. Resonance is big set. Mesomeric effect is always resonance, but resonance is always not mesomeric effect. Everyone getting my point, kids? किरण पाठक जी, आपको समझ में आ रही बात कि सारे के सारे पंजाबी, सारे के सारे तमिलियन इंडियंस हैं, बट ऑल इंडियंस जरूरी नहीं कि पंजाबी हो, आसामी हो सकते हैं, यूपीआईट्स हो सकते हैं, तमिलियन हो सकते हैं, कुछ भी हो सकते हैं कि नहीं? Got it? Now see, kids. If I take one example of this, I'm going to write like this: CH2 double bond CH NH2. Now kids, this is also pi electron and this green one is also pi electron. But which pi electron is more free, the green one or the yellow one? This is going to change your life. This is going to change your career. Remember that this yellow one is more free. Why it is more free, kids? Why this is more free? My dear students, this is bounded only by one nucleus, and it is holding by two nucleus. Two nucleus are applying force on these two electron, and this only one nucleus. Only one nucleus is applying force on this, kids. Only one nucleus is applying force. So the flow of electron will be from which side to which side? Remember that the flow of electron will be like this. If you know the flow of electron, my dear friends, then you can achieve anything. You can understand each and everything once you know the flow of electron. So the flow of electron will always be in this. The flow of electron will always be, tell me kids, flow of electron will always be, flow of electron will always be kids, do let me know, will always be from lone pair to double bond side. Once you know this thing, now you can understand anything. So I'm going to draw the resonating structure of this. Just see. Now right now, kids, this bond is looking like single bond. It's looking like single bond, and it's looking like double bond. Are you getting my point? It's looking double bond and that's looking single bond. But the intelligent student, he will say the single bond is not the pure single bond and double bond is not double bond. Thank you, Nandini, thank you. Now see, the resonance will happen and this electron will migrate. Super ting 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 ding 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 ding. It will come like this. And you will see something, you will notice like this: CH2 CH double bond NH2 positive. Now see, the double bond change into single bond and single bond converted into double bond. Can you see? So first and second are resonating structures. Can you see? I would like to say this first one and the second one, they are resonating structures, and they are not looking same. So I will say they are non-equivalent resonating structures, because this is not having charge and that is having charge. The one is without charge and the one is having charge. So they are non-equivalent resonating structures. What I will say, they are non-equivalent resonating structures. Are you getting my point, kids? Everyone? Non-equivalent resonating structures, non-equivalent resonating structures. Right? Now, what is the true structure of this? I would like to say the true structure of this is CH NH2 delta positive Single bond is having double bond character and double bond is having single bond character. There is no pure single bond. There is no pure single bond. There is no pure single bond. You got it? There is no pure single bond. Everyone got it, kids? Is this point clear to each and everyone, kids? I want to see the likes. Why so less likes are there? Everyone hit the like button. Smash the like button. I want to see more likes, kids. Baba wanna see more likes. Everyone do let me know. Everyone, kids. First of all, do let me know everyone is able to understand. Yeah, now Tamil bro, he is referring NCERT not saying electronegativity. Very good question. Very good question. How many of you want to understand this? How many of you want to understand this point that one kid has written, he is considering electronegativity. Good evening sir, voice echoes for me. Okay, I will explain it, but first of all do let me know voice echo is there, kids? Voice echo is there? Voice is perfectly, हम लाइक कर चुके हैं. Thank you. Tell me voice echo is there? Jyoti is writing. Jyoti is very good student. If Jyoti is writing something, that means a lot. Just refresh your system and do let me know, am I clearly audible and visible or voice echo is there? Voice echo is there or clearly it's okay? Thoda thoda. Okay. Kids, now do let me know. Let me check it out. Just wait. Let me check it out, kids. Hello, 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 hello. I think it should not be there, kids. It's very much clear from my side. It's very much clear, kids, from my side. Okay. Now see, kids. They are talking about the electronegativity. Let me make it more clear. Just see. CH2 double bond CH NH2. Let me make it more clear, kids. See. Electronegativity of nitrogen is electronegativity of nitrogen is 3.0 and electronegativity of this carbon is 2.75. Why 2.75? Let me tell you. If we are having single bonded, if we are having double bonded, if we are having triple bonded, then kids see triple bonded carbons electronegativity is 3.25, more than that of nitrogen 2.75, and this is 2.5. Why is this so? Its hybridization is sp3, sp2, sp. More is the S character, percentage of S character, more will be electronegativity. This point is clear, kids? More is the S character, more is the electronegativity. Electronegativity of central atom is directly proportional to bond angle, is directly proportional to the percentage of S character. Now see, if I apply minus I, if I apply what? If Baba is going to apply minus I, then this is electron withdrawing. Through minus I, it is acting as electron withdrawing group. Remember that. I would like to say through minus I, nitrogen is withdrawing electron from carbon because its electronegativity is 3. And its electronegativity is just 2.75. So this is more electronegative, my dear students. But At the same time, through mesomeric effect, it cannot control its electron. And this electron is moving from this nitrogen to this carbon. This is acting as plus M, that is plus R, as electron donating group. Electron donating group. Now kids, you will say, sir, what is this? Through minus I it is acting as electron withdrawing group, and through plus M it is acting as electron donating group. Yes, you see, if I say nitrogen is your father, Nana, and once Nana's sister is coming to your house, your father's sister is coming to your house, most of the time what will happen? Sister will give you some rupees, suppose 100 rupees they have given to you, and father has given 5,000 rupees gift to your sister. Father has given 5,000 rupees gift to sister, and sister has donated 100 rupees to this N. Now overall N is in loss or benefit. When the sister is going back to her home, sister is giving to Pandu 100 rupees, and Pandu's father has given 5,000 rupees gift to sister. So overall this is in loss. See, it is withdrawing electron through minus I. You know that minus I, through minus I, how much electrons you can withdraw in points, because inductive effect, once the inductive effect is applicable, electron is partially shifted, not completely shifted. So nitrogen has got suppose 0.2 electrons from carbon through minus I and donated 1 electron. So how much nitrogen is in loss? Nitrogen is in loss of 0.8 rupees kids. So that's why we'll say resonance, that is mesomeric effect, is dominating than inductive effect. Remember that. That's why, who is dominating effect kids? Do let me know, out of these two effect, who is dominating effect, resonance or mesomeric effect? That's why resonance is more dominating than inductive effect. You got it kids? Everyone, you got it? Just to let me know. Tamil bro, you got it or not? Tamil bro, you got your answer or not? Do let me know. By chance I have seen your confusion. Yeah, Ratan Shetty, Baba will make it very clear. Just give me a few seconds. That your confusions should not be there. That is my prime aim. I have to remove all the confusions, because if the confusions are there, they are going to kill your rank. They will kill your rank. Are you ready kids? I am going to explain it on more detail. Just see. In more detail, Baba is going to explain it. See kids, if I say this is aniline, if I say this is aniline, you know very well aniline. This is aniline kids, right? Now this benzene is electron rich. First of all, everyone do let me know, this benzene is electron rich. This nitrogen is having lone pair. The flow of electron will be from which side to which side? Do let me know the flow of electron. Ratan Sethi, the flow of electron will be from nitrogen, although the nitrogen's electronegativity is 3. Through minus I, it will withdraw electron. Minus I, if I say just minus I, it will act as electron withdrawing group. But this mesomeric effect, just see, suppose I am a very miser person, conjuice person, stingy person. Just see, if Baba is a very stingy person, suppose Baba is moving, Baba is nitrogen. Just see everyone. Suppose Baba is nitrogen and Baba is going, this is a diamond, this is gold, and this is 2000 note. It's in my pocket, right? But Baba was moving on road. Baba is nitrogen Baba. Baba was moving on road. Baba has seen 100 rupees note on the road. Now what Baba will do? Baba is moving on the road, moving towards coaching, and Baba saw 100 rupees note. Now Baba will move. Baba is a very stingy person. Baba will try to take that note, but his diamonds will fall. Once the diamonds have fallen, then Baba is in loss or benefit. Because diamonds were in the pocket only. They were not inside something like in, what to say, in safe or whatever the thing, or pocket was not zipped, not having button. Now the diamond is going to fall. So Baba is ultimately in loss. So nitrogen Baba is a stingy person, more electronegative. Through minus side will withdraw electron, but how much electron it will withdraw? 0.1, 0.2, 0.3 like that. But due to mesomeric effect, his gold or diamond will come to the benzene ring, because mesomeric effect, that is plus R, more dominating than minus I. Everyone got it. So overall there is going to be loss of nitrogen, and due to this it will make 5 resonating structures, and Baba is going to draw the actual structure, that is resonance hybrid, and that will be like this. Just see, check it out whether you are able to understand or not, and do let me know. So it has increased the electron density of benzene mainly at ortho and para position. This is the true structure, and I would like to say it is the resonance hybrid. Now see kids, it has increased the electron density. Electron density got increased mainly at what? Mainly at ortho and para position. Ortho and para. And that's why it is known as OP director. I hope that this point is clear to each and everyone. Do let me know kids. Do let me know now. Tamil, Ratan, everyone's this point is clear or not kids, do let me know. Now, let me tell you, before I move kids, let me tell you the next one, see. Next, hyperconjugation, no, resonance. Fourth type of resonance, that is positive charge pi bond conjugation. Positive charge pi bond conjugation. Now see, if I say CH2 double bond CH, CH2 positive, now the flow of electron will be from which side to which side? Do let me know the flow of electron. Now here is no electron. No electron, that means once there is no electron, that means nothing can flow. So definitely the electron will flow from this side to this side, and its resonating structure will be like this. Now they are looking like same. Just do let me know the first one and the second one, they are looking same or different. Do let me know they are looking same or different. Everyone do let me know. They are looking same or different? Same. So I would like to say they are equivalent resonating structures. Just see kids, I would like to say they are what? Equivalent resonating structures. And kids, remember that equivalent resonating structures provide more stability, provides more stability than non-equivalent resonating structures. Non-equivalent resonating structures. Now what should be the true structure of it? The true structure will look like this, kids. The true structure will look like this. Single bond will develop partial double bond, and double bond will develop partial single bond characters. So this is the true structure. Everyone got it, kids? Everyone got it or not? There is no electricity, then also Baba is teaching with the same energy. Kids, do let me know. Baba is teaching with the same energy or not? Thank you, Sahana. Kiran, are you there? Kiran, are you there? Tamil, you are getting it or not? Ratan, you are getting it or not? Do let me know, kids. Everyone, you are able to understand or not? Just to let me know, everyone is able to understand it or not? Jai Ho Baba Ki, thank you, thank you. Okay, Jyoti, thank you. Now see, kids. See, the most important thing, remember that. Point to be noted, my lord. In this case, mesomeric effect will not take place. In the following compounds, there will be no resonance. There will be no resonance, kids. See, if I write down compound like this, R C double bond O CH2 positive. Whenever you see this type of compound, whenever you see, there will be no resonance at all. Let me tell you, kids, in these two resonances possible, R C double bond O CH2 negative, resonance is possible. R C double bond O CH double bond CH2, resonance is possible. But here resonance is never possible. Remember that will decide your SN1, SN2, ARSN2, each and everything it is going to decide once you note it down, my lord, my dear students. Because oxygen is more electronegative, it will not donate its pi electron to this. This pi electron can't move, this can't go like this. Pi electron will not move. Pi electron will not move, will not move, will not move, kids. Is it clear? Now, Baba is going to tell you the most important thing, but let me ask for one glass of water, kids. Just give me 1 second, okay? Just give me 1 second. Hello? Baba is back. Okay, let me repeat. Kids, this oxygen is more electronegative. This pi bond cannot go to this carbon because the electronegativity of oxygen is 3.5. This is just 2.75. Here you see, this electron will move toward this side and this will go toward that side. There is no problem. Here also the carbon is having electron, it will go like this. No problem. But this carbon is not having no electron with this carbon. So nothing to move. Got it? Everyone got it? Chandni Nagar? Do let me know, kids. Show me some fire, green signal, green hearts if you are able to understand, kids. I want to see some fire, green hearts in the chat section if everyone is able to understand, kids. Do let me know. Now, Baba is going to tell you the most important thing. See, kids. Are you ready, kids? See, everyone. What I am going to tell you, just listen properly. Double bond conjugation is the best. Conjugation is after this I will tell you aromaticity, anti-aromaticity, and this will help you a lot over there. Then I will give questions. Are you ready, kids? Resonance can be of two atoms, that is back bonding. Resonance can be of one atom. Resonance can be mesomeric effect. Before this, let me tell you your answer to your question. Let me give you answer to your question, then I will explain this. Okay. Sahana is asking difference between mesomeric. See, kids, resonance is actually of three types. First, one atom resonance. What is this? One atom resonance. That if I say I negative is more stable than Br negative is more stable than Cl negative is more stable than F negative. This is the stability order, kids. Negative charge is more stable on biggest atom. Those students are those who are thinking that negative charge is more stable on most electronegative atom. Remember that. That is applicable only when the size of atom bearing the negative charge is same, then only negative charge most stable on most electronegative atom. But if the size is different, remember that. If size is different, then negative charge is most stable. Negative charge is most stable on biggest atom. Remember that. This is known as one atom resonance. One atom resonance. The second one is back bonding. This is also resonance. Back bonding, kids. This is known as two atom resonance. That means movement of electron, transition of electron, delocalization of electron is in between two atoms. Now see, kids. Yeah, very good. Now, third is mesomeric effect. Mesomeric effect. In this, the electron is delocalized in between three or more atoms. Remember that. Electron is delocalized in between three or more atoms, three or more atoms. So all these are resonance. 1, 2, 3. All these three are resonance, but see, this is including resonance, this is resonance, this is resonance. But resonance can be like this, can be like this, can be like this. So mesomeric effect is always resonance, but resonance is not always mesomeric effect, because resonance can be 2 atom resonance, resonance can be 1 atom resonance. Everyone, are you getting my point? Now what I was going to tell you, kids, just see what I was going to tell you. Everyone just see to that. Double bond conjugation is the best. Why this is the best? Now see, if I tell you, kids, that I am having any molecule like this, pyridine. Do you remember pyridine? Do you know pyridine, kids? Pyridine, do you remember pyridine? Now this nitrogen is having pi bond as well as it is having lone pair. It is having both the two things. It is having both the two things. It is having lone pair as well as this pi bond. Now suppose if I say I am a chef, I am having very good knife and one poor knife. Now at a time I will use which knife? The good knife, not knife, the good knife or the poor knife? At a time I can use only one knife. Which knife Baba will take? Baba will use the best, because pi bond conjugation is the best. Lone pair will remain localized. Lone pair will remain localized. Lone pair will remain localized, means it will not participate in resonance, will not do resonance. Now at the same time, kids, Baba is going to draw another compound. Just see. Now Baba will give you the feel of the subject. Those who want to get the best rank, only they can understand. This is pyrrole. Now kids, in pyrrole, nitrogen is having only one lone pair, no double bond is attached. Just see, it is just having lone pair. Now this is delocalized because it is not having pi bond. This lone pair is doing resonance. Lone pair is doing, LP is doing what? Resonance. LP is doing resonance. Everyone satisfied with these two things? In pyrrole, the lone pair is doing resonance. In pyridine, lone pair is not doing resonance. This point is clear? If clear, show me the fire. Kiran ji, very good. Kushga is there. Kushga, are you there? Kiran Pathak ji, जब तक हम पढ़ा नहीं लेते, जब तक सब कुछ बता नहीं लेते, तब तक क्लास चलेगी. So don't ask for the time, kids. At least 3 hours it will take. कम से कम 3 घंटे तो लगेंगे. सब कुछ अच्छे से पढ़ाना है kids. Kids, अपने दोस्तों को बुला लो. बाबा इतनी important चीज बता रहा है. बाबा is going to tell you very important thing, kids. Everyone be ready. Baba want to see fire in the chat section. Green heart, kids. Now see, kids. If lone pair is delocalized or localized, so its steric number, once I am going to count steric number, then I will say 1 sigma, 2 sigma and lone pair, 2 plus 1, 3. So its hybridization is sp2. This is planar, molecule planar. Now here, lone pair is doing resonance, so 1 sigma, 1 sigma, 1 sigma, so steric number will come out to be 3 plus 0. Here also the hybridization is sp2 and this is also planar. Both are being planar, kids. Both of them are planar, but once I will say pyrrole's lone pair is moving, doing resonance, but pyridine's lone pair is localized, so is more basic. Definitely this one is more basic. Why it is more basic? Because its lone pair can't move, so proton will attack easily here. Proton will easily attack on the nitrogen's lone pair of pyridine. Kids, agreed? Agreed? Now, let me tell you one more thing. Suppose I am provided a compound like this, see kids, double bond along with positive charge, just see, positive charge, double bond along with positive charge, just see kids. If I say I have got one compound like this and I am going to compare with this, I am having another compound like this. Now which one is more stable? This is first, this is second one. Who is more stable? This is, you can consider it to be the question. So who is more stable? Just I want answer in the chat section, everyone. Now definitely this is more stable. Now you will ask, sir, why this is more stable? Ask me kids, why this is more stable? Because here the positive charge is along with the double bond, so double bond, the resonance is going on, but this is localized, means not taking part in resonance. So just like other people's, they are doing party, but they are saying, hey, positive charge, we are not going to give you party, though he is crying, hey, everyone is enjoying in the party, but they are not including me. But here less people, they are doing party, but they are saying, hey, you are also the part of our party. So he is delocalized, he is the part of the party, he is not the part of party. So this positive charge is feeling very bad. Hey, you are not giving me the chance, why you are doing so? Are you getting my point, kids? Everyone do let me know. So it's angry. Now let me tell you, if the compound is given like this, same thing, that they are enjoying party but negative charge, localized. Now it's better than this. Less people, they are doing party, but they are saying, hey bro, Anna, you are also the part of the party. So he is happy. Why he is happy? Because it's delocalized. But he is angry because they are not making him the part of the party. Are you getting my point, kids? This is going to help you whenever we are going to deal with the question. See kids, there is no electricity, but then also no AC, kids. Baba is teaching without AC right now, kids. There is no AC, but then also Baba is teaching you with full energy. Now kids, everyone, are you getting my point? This point. Now see, Baba is going to tell you the applications of resonance. Everyone ready? Applications. Now I will give questions, number of questions, kids. Applications of resonance. Everyone ready for this? Everyone ready for this, kids? Applications of resonance. Everyone ready, kids? Do let me know. Now let's see first application. Let's deal with the first application. Aromaticity. Anti-aromaticity. Kids, I will cover both the two things, aromaticity, anti-aromaticity, both together. But let me tell you, kids, let me tell you, once I am going to tell you 2 points, then I will ask number of questions. Everyone ready, kids? Wow, thank you, Vasu, thank you. Only legends know who and what Baba is, HSP is. Wow, wow, kids, thank you, thank you. Now see. Let me tell you, kids, aromatic compounds are highly stable. Aromatic compounds are highly stable. Everyone wants to become aromatic. Then non-aromatic. And kids, least stable are anti-aromatic. These are highly unstable. Highly unstable. So this is the stability order. Gets clear? This is the stability order. Is this clear to your brain? Anti-aromatic compound says, hey God, I don't want to become anti-aromatic. Either convert me into aromatic or non-aromatic. Okay? Now see, kids. Now see, kids. What is required for a compound to be aromatic? What is required for a compound to be aromatic? At least one planar or slightly planar ring, slightly planar ring. At least one planar or slightly planar ring. Okay? And this ring must follow Huckel's rule. What is that? That is number of delocalized pi electrons. Delocalized pi electrons. Number of delocalized pi electron should be 2 pi, add 4 to this, 6 pi, 10 pi, 14 pi, and so on. Gets clear? Delocalized pi electron should be like this. This is the Huckel's rule. This point is clear to each and everyone. Now, simultaneously, I am going to tell you anti-aromatic. Thank you, Kiran Pathak. Thank you. Simultaneously, I am going to tell you anti-aromatic. Just see, for a compound to be anti-aromatic, at least one planar or slightly planar ring. Now this point is common. Can you see? The first point is common in between aromatic and anti-aromatic. Can you see, kids? And this cycle must contain number of pi electrons in multiple of 4, in multiple of 4, that is 4 pi, 4 2s are 8 pi, 12 pi, and so on. Got it? This is the only difference between aromatic and anti-aromatic. Remember that for a compound to be aromatic or anti-aromatic, first of all we have to see one planar ring. If planar ring is not there, that compound can never be aromatic, anti-aromatic. Are you getting my point? Let me tell you one thing very clear, kids. Let me tell you one thing very clear. For a compound to be aromatic or anti-aromatic, what is necessary? What is necessary? One, at least one, better to say at least. If it is more than that, no problem. At least one planar ring. If there is no ring, compound can't be aromatic or anti-aromatic. This point is clear. Has it gone to your hippocampus? Now, why people are getting failed? They never see the ring. They always count pi electron. They are involved. They are indulged. Most of the time they are indulged in counting pi electron. Never count pi electron first. Now, question. Are you ready, kids? Question. Everyone ready for the question? Do let me know. Hey kids, is everyone ready for the question? Do let me know. Question is, find out total number of aromatic compounds. Ready, kids? Are you ready, kids? Okay, let's see kids, let's see. Tell me in the chat section, how many are aromatic, kids? How many of them are aromatic? I want to see your answer. Fast. Kids, fast. Fast kids, fast. Six. Some kids are saying 6. 6. Okay, let me check it out. sp3 non-planar, not answer. Planar 1, 2, 3, 4, 5, 6. Aromatic 1, 2, 3, 4. Anti-aromatic 1, 2, 3, 4, 5, 6, and this is localized. So planar following Huckel's rule, 6 pi electrons. Aromatic 1, 2, 3, 4, 5, 6. Aromatic 1, 2, 3, 4, 5, 6. This is delocalized, this is localized. So aromatic 1, 2. Aromatic. How many are aromatic? 1, 2, 3, 4, 5, 6. Wow, kids. Congratulations. Those who have given 6 answers, really awesome. Wow, kids. Now Baba is happy, super happy. Congratulations. Now Baba is going to give you another question. My dear students, you made my day. You made my day. Number of aromatic compounds. A, B and C. A, B and C. How many of these are aromatic? Kids, do let me know. Let me tell you, this is carbon. This is carbon. This is carbon, double bond carbon. Tell me, kids. Now it's your time. Everyone, do let me know. How many are aromatic out of these? Kids, do let me know how many are aromatic. Now see. Wow, Sahana, all are aromatic. All are aromatic. Very good. All are aromatic. See why. This oxygen's electronegativity is 3.5. It is 2.75. So this electron will migrate toward this side and it will look like this. Now see, the ring is having just 2 pi electrons, aromatic. So if you apply thermodynamics, examiner can give you a question like this. Delta G for this process is negative. This means this will move towards this and its dipole moment is greater than 0. That means this compound is polar. He can reach up to the polarity. Number of questions can be asked from here. Now say, this is known as tropolone. Remember that it is given in NCERT, tropolone. Oxygen will withdraw electron and it will look like this. aromatic. Here also the process is feasible. Delta G is negative for this. Now here there are two rings, remember that. Both the rings are sharing this pi electron. One ring is saying, hey, I want to gain electron. Another ring is saying, hey, just take electron. So this ring is saying, hey, electron, inge ba, inge ba, inge ba. And this is saying, just go, po, po, po. This is calling inge ba, and this is saying, po, just go. Now how they will look like after gaining and donating electron, just see. This is the point to be noted, my lord. After donating electron it will look like this, and after gaining electron it will look like this. Just see, kids, everyone. Hey, this is the point to be noted, my lord. Just see. Sajir, Modadhir, Rathi, everyone. I can see everyone. Ratan Sethi. Kids, don't say like that. Kids, Baba can see everyone, my dear friends. Ratan Sethi is there. Baba can see everyone, kids. Kids, Baba can see everyone. Kids, everyone is important for Baba, kids. Baba never do partiality. Everyone, you are my child and I respect each and everyone, kids. Little Cupid is there. Ratan Sethi is there. Now see, kids, after gaining electrons, see, earlier it was having 1, 2, 3, 4 and 5 pi electron. It was having 5 pi electrons. And it was having 1, 2, 3 pi electrons. Now it is having how many pi electrons? 1, 2, 3, 4, 5, 6 pi electrons, and it is having 2 pi electrons. Both the rings got benefited or not? First of all, tell me, kids. Akhilesh Gaming, thank you. थर्ड नहीं आया, मैं अच्छे से सिखाऊंगा, डोंट वरी, थर्ड भी आएगा, यू विल गेट इट. लास्ट वन कंफ्यूज्ड, डोंट वरी, बाबा विल टेल यू इन डिटेल. This ring has become aromatic and this ring also has become aromatic, so all. Now once the ring one is not clear, Baba will tell you in detail. Okay, how many of you want this one in detail, third one? And that's why I am always asking, the communication should be better over there. In the chat section, write down clearly, sir, I am unable to understand. Please tell me once again. Baba will tell you 100 times, kids. That's why in the chat you have to write, once it is clear, show me green hearts. Once it is not clear, show me fire. The third one, if it is clear, show me green hearts. If it is not clear, show me fire, because Baba can see the fire and the green hearts clearly in the chat section, and I'm promising that I will explain it. I'm damn sure that definitely Baba will explain it. Baba is having those guts. Thank you. And kids, call your friends. Baba is doing such a hard work. Everyone, call your friends. Tell them, let's celebrate 15th of August with this teaching, this understanding, these notes. Call everyone, kids, your friends. At least one friend you have to tell them, come on, Baba is dealing with questions. Now let's see, kids. If I am drawing rings like this, see, kids, number of rings. If I draw a ring like this, if I draw a ring like this, Now kids, remember that. In these two rings, what is common? What is common in between these two rings? A and B. That both the two rings are same. This is a common point, kids. Wow, thank you, Sana. In both the two rings, common point both the two rings are having same number of carbons and electrons. Right, kids? Right, kids? Is this point clear to all of you kids? Do let me know. Is this point clear? Both the two rings are having same number of carbons and same. Whenever you see such type of compound, electron will never move. It will always have frozen rotation. Remember that. Symmetry is there. I can say whenever symmetry is there, whenever there is symmetry, this pi bond will never move. Pi bond will always have frozen rotation. What is this frozen rotation, kids? Frozen rotation. What do you mean by this frozen rotation? That means pi bond will not move. Pi bond will not move. Pi bond will not move. Why pi bond will not move? Pi bond will not move. Kids, why? Question arises, kids. Baba, just explain why the pi bond is not going to move. We want to know. Kids, everyone wants to know. Now see, right now this ring is having how many pi electrons? 5. 5, 1, 2, 3, 4, 5. And this is also having 5. Right now it is non-aromatic. It is non-aromatic. Right? And the same thing is over here. This ring is also having 1, 2, 3. 1, 2, 3, non-aromatic. Kids, is it clear? Is it clear? Now, if any of the ring is accepting electron, suppose if I say that ring is accepting electron, now see what is going to happen. Once this ring has taken electron, it will look like this, and this will look like this. Now kids, see in detail. 1, 2, 3, 4, 5, 6. It has become aromatic. And 1, 2, 3, 4. It has become anti-aromatic. Now kids, this is the family. This is the family. Now see this family with the eye of mother. One Anna has become Karorpati and one Anna is suffering with cancer. One brother is suffering with cancer. And one brother has become millionaire. Now, what do you think? Mother is going to be happy or unhappy? Tell me, mother will be happy or unhappy? Because sum of aromatic plus anti-aromatic will come out ultimately anti-aromatic. Now the whole family is suffering with cancer. Do you think anyone is going to be happy in this family? If one brother Anna is suffering with cancer and one has become millionaire, so this is not possible at all. This is wrong. So that ring will not show movement. Whenever two rings are same, pi bond will never move. Pi bond will never move. Oh mera bachcha, yes, oh mera bachcha. Kids, this point is clear to all of you. Once in a compound, one ring is aromatic, another ring is anti-aromatic, one is aromatic. Ultimately, it is going to be anti-aromatic. Now see, let me give you another example. Just see, kids. Whenever one ring is like this, just see. Now, it's something when it is going away from your life, and once it is going away from the life and you are feeling happy, then you will say, oh, let it go, let it go. Now see, this ring is saying, the upper ring is saying, I'm having 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Right now this ring is neither aromatic nor anti-aromatic. So it is non-aromatic ring. Now see over here. It is having 1, 2, 3, 4, 5. This is also non-aromatic. Now see, kids. The upper ring A and the lower ring B, what they are talking, what they will say about this pi bond, what they will talk about this pi bond. One ring is saying, hey electron, just poda, ja, go. Another ring is calling, hey electron, come here, inge va, everyday va, just come over here, aja, electron mera, ja, electron tera, ta. This ring is saying, just go away. This ring is saying, just come over here. Just see to it. Now, what is going to happen? Ding. La. It will be like this. Both the rings will be happier. Wow. Now, see, kids. The upper ring is having now 6 pi electrons. It is planar. Huckel's rule is followed. 6 pi electrons has become aromatic. Now this is also having 1, 2, 3, 4, 5, 6. Huckel's rule followed. Planarity rule follows. 6 pi electrons aromatic. Now both the rings are happy. So we will say, according to thermodynamics, its delta G will be negative for this process. Process is feasible. This compound is highly polar. Highly polar compound. Highly polar compound. This pi bond is not having frozen rotation, it is having free rotation, it is free to move. This pi bond is having free rotation. Pi bond is having what? Free rotation. Got it, kids? Everyone got it? Now, how much time is gone, kids? 2 hours. Should we take one break, kids? Should we take one break or no break? Tell me, should we take one break or no break? Kids, do let me know. Ratan Shetty, what you will say, I will follow. Kids, should we take one small break? Jyoti Jain, wow, Jyoti Jain. After break, we will solve number of questions. I was waiting for you. Kids, hit the like button, smash the like button. Baba is teaching without AC. There is power cut on this day. 10 minutes break. Okay, kids. Okay. Kanishka, no break. break, no break, small break. Tamil, small break. So let's take very small break, 10 minutes break. Okay, kids? Okay, kids? But promise, make a promise, kids, that you will come with your friends. Everyone will come along with one friend. Everyone will come. Let's meet at 9:30. Let's meet at 9:30. Okay, kids? Kids, make a promise that you will come with one friend along with. Okay, Jyoti Jain, that's why I was thinking power cut ho gaya. Same here also. Okay, no problem. Namaskaram, Abhivadanam, Suswagatam. Baba is back. Kids, do let me know. Can you hear me? Can you see me? If yes, I want to see some fire along with green hearts, green signal in the chat section. Everyone. Now, those who are unable to understand the difference between aromatic and anti-aromatic, let me tell you, my dear friends, I will make it super duper clear. Just show me fire in the chat section if there is problem in between aromatic and anti-aromatic. Just see it. Yeah. This side, oh ho ho, why? Hey board, please cooperate. Aromatic. Anti-aromatic. Let's see what's the basic difference. If I draw ring like this, if I draw ring like this, now see, both are planar. Both are planar. All carbons are sp2 hybridized. Now, this ring is having how many pi electrons? 2 pi electrons. So, aromatic. It is having 1, 2, 3, 4 pi electrons. So, if the pi electrons are in the multiple of 4, 4 1 ja 4, 4 2 ja 8, 12, 16 like that, then that compound is going to be anti-aromatic. Are you getting my point, kids? Anti-aromatic. This point is clear to each and everyone or not? Do let me know, kids, in the chat section. I want to see you answer everyone's answer, kids. Is this clear to each and everyone or not? Show me some fire, kids. I can't see any chats. Kailash Yadav, Little, Jyoti Jain, do let me know, kids. Do let me know. Is it clear? Clear, right, okay. Now see. If I give you, kids, the second application, if I talk about second application, just see. But before moving towards second application, find out, question is, let me check it out. How much do you know? How many compounds are aromatic? Are aromatic? One, two, three, four, five. So these are the 5 compounds. Just to let me know how many of them are aromatic, kids. Tell me. There are 5 compounds. Out of these 5 compounds, do let me know, kids. Out of 5 compounds, how many? Now 5, 1, 2, 3, 4. Only 4 compounds are there. Out of 4 compounds, how many of them are aromatic? Do let me know, kids. So the answer is, this is sp2 hybridized and its one lone pair is delocalized, another lone pair is localized. So the pi electrons which are taking part in resonance are 1, 2, 3, 4, 5 and 6, that is following Huckel's rule. So it is declared to be aromatic. Now here this is sp2 hybridized because boron, this is also sp2 hybridized, so ring is planar. And how many pi electrons? 2 pi electrons. So it is following Huckel's rule. This is also declared to be aromatic. 1, 2 pi electrons, so this is declared to be aromatic. And see, this will move toward this side, this will also move toward this side, and it will look like this. Negative, negative, positive, positive. Now see, all three rings have become aromatic. See kids, all the three rings are aromatic now. Just see, 1, 2, 3, 4, 5, 6 pi electrons, 2 pi electrons and 2 pi electrons. So all three rings are aromatic, So all four are aromatic kids. All four are aromatic and its polarity is very high. Dipole moment is greater than 0. Polarity is very high. Got it kids? Kids, everyone, thank you. Khushbu, Rashid, Thamil, Born Vampire, you got it? Delocalized and localized nahi aaya, don't worry. Let me make it clear. Delocalized and localized. I have told you resonance. Just see. Let me make it clear. Just see how to find out delocalized and localized. See. Delocalized and localized, how will you find out? Just see. If there is one ring and there is any charge, over here, any charge, positive, negative, any charge, that will always be localized, If there is ring and the charge is on the double bond, any charge, positive or negative, that is always localized. In these two cases, charge will always be localized. Just see kids. Now, if the ring, same ring, but if the charge is adjacent to that double bond, positive or negative, they will be delocalized. Now you got it? Delocalized. Vampire, now is it clear? In case B, this is always localized, but here it is delocalized. Now is it clear? You got it? Yeah. Boron is having pure p orbital. Thamil, you got it. Everyone got it. Kids, do let me know. First of all, do let me know. Is it clear to all of you or not? Echo is there. Ratan Sethi. Echo is there. Kids. Do let me know. My voice is clear or echo is there? Voice is not clear. Echoing. Just wait. Hello. Hello, 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 hello. Hello, 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 hello. Hello, 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 hello. Hello, 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 hello. Now check kids, now check. Now is it okay? Hello, 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 hello. Now is it okay? Kids? Hello, 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 hello. Hello, 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 hello. Now just to let me know kids. Now is it okay? Hello, hello, hello. Now is it okay kids? Now is it okay kids? Kids, do let me know in the chat section, is it okay or not? Hello, 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 hello. Hello, 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 hello. Hello, 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 hello. Now check kids. Kids, do let me know in the chat section, now is it okay? Baba is now do let me know kids. Show me green. Show me the green signal if it is fine kids. Baba, previous slide B is aromatic. Let me see. Previous slide. Yeah, it's aromatic. B is aromatic. Aromatic. Now first of all, now do let me know. Now the sound is clear, voice is clear kids. Okay. Now see. A. This is having two lone pair. Out of two lone pair, only one can take part in resonance. Out of two lone pair, only one can take part in resonance. Yeah, I will teach. NEET warrior, I will teach. Out of two lone pairs, let me tell you. Remember that kids. Note, if any element is having more than one lone pair, then only one will do resonance, others will remain localized. For example, if I say CH2 double bond CH NH2, it is having one lone pair, so delocalized. It is having two lone pairs, one is delocalized, another one localized. It is having three lone pairs, one is delocalized, rest are localized. Got it kids? This will be the situation. Now everyone got it? Everyone got it kids? Now do let me know in the chat section, this point is clear or not. If any fighter is having more than one gun, or more than one sword, or any mummy is having more than one knife, then at a time how many knives can be used, how many swords can be used, how many guns can be used? Only one. Rest of others you have to keep aside. Got it, everyone? Walaikum salam Bhatt Saista, walaikum salam. Now this point is clear. Now let me tell you one more point before I move ahead. Let me tell you one more point. Let me make one more point clear, that always resonance is better than, I would like to say, resonance is more effective than whom? Inductive effect. If I say they are opposing, then I will say plus M or plus R is more dominating than minus I. But remember that, my dear students, in case of halogens, point to be noted, my lord. Note, in case of halogens, minus I is either equal to or greater than plus M, that is plus R. Remember that. This is one thing, one point to be noted, my dear students. This is very, very important point. It holds a hell lot of weightage. See, that's why when it is equal, minus I is approximately equal to plus M, that is plus R, when it is the case of, in case of fluorine. And that's why kids, the acidic strength of phenol and parafluorophenol is exactly same. Both are equally strong acids. Their acidic strength is same. Remember that. 1.9 into 10 raised to power minus 10 Ka value, both are having the same Ka value, and this is the reason. That I can say this is the consequence, this is the result. Now you will say, why sir, why? Why this is happening? You must want to know the reason, but halogens are orthoparadicting. I will tell you kids. See, if I say any group is here attached at this position, if I say whether NH2 is there, whether OH is there, they are orthoparadirecting, right? As well as making ring more electron rich, as well as making benzene ring more electron rich. But kids, if I talk about halobenzene, if I talk about halobenzene like this, its minus I is more dominating than plus M. Remember this point kids, mark my words, write it down, note it down kids. Now, its ring activity is decided by, ring activity is controlled by minus I. So it is deactivating the benzene ring. Remember that. It is deactivating benzene ring. Mark my words kids. It is deactivating benzene ring. So it is less electron rich than benzene, and that's why it is less electron rich than benzene. But its orientation is controlled by mesomeric effect. Remember that, my dear students, what I am telling you. Its orientation is controlled by whom? Is controlled by plus M, and that's why it is OP director. OP director. So I can say all ortho and para directing groups are ring activating except halogens. I am going to write down one point. Okay, Imam, what's your question? Imam, repeat your question. What's your question, Imam? I want to see your question, Imam. Tell me what's your question. Tell me what's your question, Imam. Now, I will say what I am going to tell you, kids. Remember one point very clearly, kids. This is the reason why all ortho and para directors are ring activating. Except whom, kids? Except halobenzene, which are ortho director, para director, ortho and para director, but ring deactivating group, and the reason is simple. Ring deactivating group, and the reason is simple. What is the reason, kids? Here the reason is different and there the reason is different. What is the reason different and why it is being different? Just see to it, kids. I would like to say here mesomeric effect is dominating than minus I, and here minus I is dominating than plus N. This is the simple thing and point to be noted, my lord. Always remember. Sir, organic chemistry lesson wise can be expected. Yeah, Arjun. I will teach you organic chemistry lesson wise. But first GOC. Let me make GOC very clear. Okay? Kids? Clear? Make it 100, kids. Smash the like button. Kids, at least make it 100. Can I expect that much from your side, kids? You are going to make it 100? Oh, it's already 103. So, it was not updated for me. Now see, kids, application number 2. Are you ready? For application number 2, everyone is ready, kids. Do let me know. Show me some green hearts. I want to see some green hearts, some fire in the chat section. Second application, Baba is going to deal with application number 2, kids. Are you ready for that? Acidic strength. Second application is acidic strength. So first of all, I would like to tell you, you have to know how to apply inductive effect, mesomeric effect. Before applying it, let me tell you once again, because number of students, they are unable to apply these things. Let me tell you once again, kids, if I say this is benzene, and if any group is attached at this place, then according to this group, This is going to its ortho position. This is going to be para, just para, and this meta. And remember that inductive effect at ortho is greater than meta is greater than para. Remember that. Remember that. In the first lecture of GOC, I taught you inductive effect and hyperconjugation, I and H, and now today I told you mesomeric and resonance, right? So remember that if I say that mesomeric effect gets mesomeric effect or resonance, mesomeric, that is a resonance, or if I talk about hyperconjugation, remember that these never depends on distance. These are not dependent on distance. Remember that what I am telling you, kids, they never depend on distance. They are distance independent. Kids, is it clear? This was distance dependent. This was your distance dependent, kids. Now these are independent of distance. Then I will give you questions, kids. Then only I will give you questions. Remember that mesomeric effect, resonance, or hyperconjugation at ortho will be equal to at para. Just remember my words, MRH. They are not effective from meta, not effective from meta. They are not effective from meta. Remember this word. They are never effective from meta. If this point is clear, then only I am going to, yeah, pen hit on note. Yes, doctor, nurses and patients. Kids, is this point clear? Then only Baba is going to give you question. Duration, don't worry about duration, kids. Just remember that. Let me complete it. Baba is teaching without AC. No electricity is at right now at my home. Electricity cut is there. The class is going on behalf of inverter. Then also Baba is teaching now. Now, ठीक है? Now see, acidic strength. If I give you question like this, one question, arrange in decreasing order of acidic strength. Arrange in decreasing order of what? Acidic strength. Or they can give you an order of decreasing Ka, or they can give you increasing order of pKa, right, kids? All they mean same. All they mean same. Are you ready, kids? Is everyone ready, kids? Now see, if I give you question like this, now these are 4 compounds, nitrophenols. Do let me know their acidic strength. This is A, B, C, D. Who is most acidic? First of all, do let me know who is being most acidic. I'm waiting for your answer, kids. Who is most acidic? Do let me know, kids. Who is being most acidic? Baba is waiting for your answer, kids. Yes, Jyoti, yes. Now everyone, who is being most acidic? Baba is waiting. B, C, A, D, A, B, C, D. Oh my God. Number of answers are coming, kids. Number of answers. B is most acidic. Kids, everyone is going for B. And definitely B would have been the answer. But there is one twist. There is one twist. B is having something. H is saying to oxygen, hey dear, I'm strongly attached with you through. I'm strongly attached with you through intramolecular hydrogen bonding. Hey, chelation. Intramolecular hydrogen bonding is there. This is known as chelation. This is known as what? Chelation. That's why it got defeated. Otherwise, B was supposed to be most acidic, but B is not the answer, kids. Remember that. It lost. That's why it is the winner. So the answer will be A, then B, then C, then D. Kids, how many of you got shocked with this answer? How many of you got shocked? This is most acidic, kids. This is being most acidic. And only a bit of difference is there. Its pKa value is 7.14. Its pKa value is 7.24. Its pKa value is 8.34 and its pKa value is approximately 10. Less is the pKa, most is acidic. Less pKa, more acidic. So remember that whenever nitrophenol is coming, pom pom pop pop pom. Remember this song, pom pom pop pop pom, for which this song is valid only for nitrophenol. Nitrophenol song. This is the trick. Pom pom pop pop pom. Will you be able to remember it, kids? Will you be able to remember it, kids? Do let me know. Will you be able to learn it? pKa. Let me tell you what is pKa. Remember that one thing, acidic strength is directly proportional to Ka value. This Ka comes from law of mass action, class 11th, and inversely proportional to pKa, because pKa is just reverse of Ka. pKa is equal to minus log of Ka. pK is just inverse of minus of pKa, so it is opposite, and this you will study in ionic equilibrium. Where you will study, kids? Ionic equilibrium chapter. You will study it, ionic equilibrium. Got it, kids? Everyone got it? Now I think you got tired, kids. You got tired. Now Baba is going to give you one more question. Just see. If I say, kids, there is 3 NO2 groups. There is 3 NO2 groups, kids. If I say there are 3 NO2 groups, what I am telling you, there are 3 NO2 groups. A, B is with 2 NO2 groups. C is with 1 NO2 group. And D is without NO2 group. Now kids, Baba is going to give you one thumb rule. Remember that. Baba is going to give you one thumb rule. Each addition of NO2 group decreases pKa value approximately by 3. If I say its pKa value is how much? Its pKa value is how much, kids? Its pKa value is how much, kids? Do let me know. Its pKa value is how much? How much I have told you, kids? 10, approximately 10. I have told you or not? Its pKa value is approximately 10. Then decrease 3 from here, 7.14, decrease 2, 3, 6, so 4.20 approximately. So 10 minus 9, approximately 1, and this is known as picric acid. Most acidic. So the acidic strength order is like this. Am I right, kids? The acidic strength order is like this. Am I right or wrong, kids? Do let me know. Am I right or wrong? Everyone do let me know. Am I right or wrong? Baba want to know that you got it or not, kids. Now kids, Baba is going to tell you ortho effect, then I will give question, right? Should I explain ortho effect, kids? First of all, should I explain ortho effect? Now see, then I will give question. First let me explain ortho effect, then I will give you question, right, kids? Ortho effect says any group electron donating group or electron withdrawing group, irrespective of that. This is very important thing, very important thing. Any group electron donating or withdrawing or bigger atom like bromine iodine, when attached at ortho position with respect to COOH. Remember that what I am saying, with respect to COH. Never apply ortho effect in phenol, never apply ortho effect in aniline. What I am telling you, benzoic acid, they will increase acidic strength, will make compound more acidic, will make compound more acidic than whom? More acidic, will make compound more acidic. So this ortho effect I am talking only when they are attached at ortho position with respect to COH. This position if the group is there, this position if the group is there. Now let me tell you, first of all, let me give you one example. Then only you people can solve question, right kids? Let me teach you, then only you can do it kids, otherwise you won't be able to do it. So Baba will teach first, then Baba will give questions. Remember that if I say that I am having benzoic acid and the group is bigger group, bulkier group, like if I say CH3, 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 it is occupying too much space. It is not the factor of electron donation, it is the factor of occupying a space. It is referring with the space occupying, how much space that thing is occupying, how much steric hindrance that is making. This is more acidic if I compare with this compound. Just see. Why it is less than that? Because it is occupying less space. It is occupying less space. Now, if I say it is even less acidic than this, because it is at only one position, only one side. Now you will say how it is going to affect the acidic strength. So I am little bit confused. I am unable to understand how this acidic strength is valid kids. How many of you want to understand? Do let me know. Show me some fire in the chat section if you want to know the explanation for it. If you want to understand kids, show me some fire in the chat section. I can see number of people, they are not that much consistent. If people are not consistent, then how they will get rank kids? They are not able to sit for 3 hours. Baba is teaching without AC and continuously Baba is teaching kids. Now kids, here the reason is steric hindrance. Now how it will work? Simply, the reason is steric hindrance. Now this steric hindrance, how it will explain the reason? How many of you want to know? Everyone show me fire. I can see Tamil is very consistent, Jeevan is consistent, but Ratan Shetty, you are consistent, and Sahana is very consistent. Get see, I am sitting without fan. Oh my God. Nitesh, Jyoti is consistent. Now Huda and everyone, I want to see some fire for this student who is sitting without fan. The one who is sitting without fan, I want to see some fire for that student. Now see kids. Just see, if I tell you this is C double bond O, this is O negative, and here C double bond O, O negative, and the groups are here. Now kids, if I say this is the patient, this is the patient, and if I say this is doctor, this is doctor, and now these are normal patients, they are not in need of doctor, normal patients. These pi bonds are normal patients, right? This is serious patient, serious, suffering with some disease, serious patient, right? Now kids, this doctor, when this doctor is going to visit this patient, then this patient is feeling good. But doctor, when it is going to the normal patients, it is coming after a very long period of time, and for that much of time this will remain localized and will not be feeling good. But here this patient has appointed bodyguards. What? Bodyguards. Now this doctor cannot go inside the benzene ring. This doctor cannot visit this ring. Now it will do full-time resonance with this. This doctor will do full-time resonance with this patient, in which case patient is feeling better. Serious patient is getting more availability of doctor. Just to let me know which patient, this patient is getting more availability of doctor. In the first case he is getting more availability of doctor, or in the second case the serious patient is getting more availability of doctor. Just to let me know kids. Thank you Kiranji, thank you. So the answer lies in this case. In this case, this conjugate base is more stable. This conjugate base is more stable. Now kids, till now I have told you the story of doctor and patient. Till now I have told you the story of doctor and patient. MB, thank you. Born Vampire, thank you. But now I will tell you the chemistry of this. This here full attention, this patient is getting full attention, right? This was the reason patient was getting full attention. This patient was getting attention like family doctor. Now here the doctor has become family doctor. Here the doctor has become like what? Here the doctor has become family doctor. Am I right? Here the doctor has become family doctor. Am I right or not? Now let me tell you the chemistry behind it. Chemistry behind it is, here this is doing resonance with benzene as well as non-equivalent resonating structures. We got non-equivalent resonating structures. And there kids, due to steric hindrance, we got equivalent resonating structures. Now tell me kids, who will provide more stability? Equivalent resonating structures will provide more stability or non-equivalent? Tell me kids, who will provide more stability? Equivalent resonating structures will provide more stability or non-equivalent? Just to let me know. This will provide more stability. This will provide kids. This will provide what? This will provide more stability. Am I right or wrong kids? Do let me know. Am I right or wrong? Just do let me know one thing. Am I right or wrong? Everyone. Side please. Okay. So definitely this is going to provide more stability kids. This will be more stable than this, because this pi bond, when it's coming to benzene, it is forming non-equivalent resonating structures, and that is always forming equivalent resonating structures, kid. Am I right or wrong? Am I right or wrong, kids? Do let me know. If you got it this point, at least show me some fire or green hearts. Walaikum salam Bhatt Sasya ji. Everyone do let me know you are getting this point or not. So much clear, Kiran Pathak. Very good. Thank you. Thank you. I'm liking it, kids. That's really awesome. Now, after telling you this much, Baba is going to give you one superb question, simple question, most frequently asked question. Are you ready? Is everyone ready? Show me some fire. Everyone, along with green hearts, I want to see some fire, kids. Baba want to see some fire in the chat section. What happened to it, kids? I think it's not working. Let me wait for some time, kids. I think it got heat up. I think the board got heat up. Yeah, board is not tired, but I think board got heat up because no electricity. And Baba is teaching without electricity, without AC. There is no AC. So just wait, kids. Let me give some air to this so that it will feel better. Let me open all the doors and windows. Let the fresh air should come inside. Now, hey board, please start working, kids. Everyone pray to God. Hey board, please start working. Hey board, please. Yeah, oh my God, see, kids. It's following. It's following. It's following. See, kids. God is there. See, kids. God is there. God is there. God is there. See, God is there. And see, God love you. Yes, do let me know. What's your answer? Do let me know. Oh, yeah. Vampire, I can see your message. Vampire is saying our battery is fully charged, but mobiles, charge it, kids, and do let me know what's the answer. Everyone, do let me know what's your answer. Baba wanna see your answer, kids. Baba is waiting for your answer, kids. Everyone, do let me know. Those who are new, subscribe our channel. Those who are new, hit the like button, kids. Yes, kids. And kids, let me tell you once again, you can help others with this, kids, this slide. This valid till 14th of August, but you can ask, then they can give you for 15th also, kids. Okay. So help others by getting it. Apply code HSP 10, kids. Let's see now. Here is your question. So what's your answer? Baba is waiting for your answer, kids. DBCA. DBCA. Everyone is going for DBCA. Are you sure? Everyone is sure? Or you want to change your answer? Your answer is wrong. Would you like to change your answer, or you want to go with DBCA, kids? You want to go with DBCA or you want to change your answer, kids? Now see, you made one mistake. You screwed up. See, what's that? Here is give me some sunshine, give me some rays, give me another chance, I want to grow up again. Yeah. You missed it, ta. You got trapped. Ortho effect. You missed it. Ortho effect, kids. Most of the time you will miss it, and that's why you will miss it. This will be most acidic first point. Got it? Everyone, got it or not? You missed it? You missed it or not? Do let me know. I want to see those who have missed it. Everyone missed it. I want to see fire from each and every one of you. That's your punishment. Only 1 or 2 students have given the correct answer. Rest of others missed it. Everyone, show me some fire for your mistake. After this, we will apply brain. D. After that, D. Then after D, B. Then at the last, C. How many of you are saying that this is not the correct answer? This is my answer, kids, of acidic strength. This is my answer. This is Baba's answer. Tell me. Tell me, kids. Everyone, tell me. Here is ortho effect. Now see, let me explain it. Meta, from meta only plus I will work. Plus I, it will donate electron through plus I. Take my electron, ting. Negative charge will increase. Charge increased, stability decreased, acidic strength decreased. This will apply hyperconjugation and plus I. From para, hyperconjugation and plus I. So charge will get increased too much. Charge will increase too much. Stability will decrease too much. Acidic strength will decrease too much. So this is least basic. C is least basic. How many of you got it? How many of you got it? And how many of you want one more question based on this? How many of you want one more question? See, Baba is going to give you one more question so that you can do it. You want one more question or you don't want? Tell me. Yes, do it, kids. Now your time. Ball is in your court, kids. Baba want to see your answer in the chat. Let's see who is going to give correct answer this time, kids. I will wait for your answer. Right now I am taking class from Lucknow. This class I am taking from Lucknow, kids. Shubh from Lucknow. ADCB. Sahana, would you like to change your answer, kids? Or you will go with this option only? Bhaiyo or Behnos, Devi or Sajjano, would you like to change your answer? Jyoti, would you like to change your answer? Ratan Shetty is going with ABDC. I think Ratan Shetty is correct. Ratan Shetty, everyone claps for Ratan Shetty Siddharth. Ratan Shetty Siddharth. Everyone, huge round of applause for Ratan Shetty and Siddharth. See, the answer is, the correct answer is A, B, D, C. Now ask me why, kids. Ask me why. Just ask me why, kids. Who will ask, kids? Who will ask why? How many of you want to know? See, divide it. How will you divide it, kids? Divide it like this. These two are loins, loin. And these two are doggies. Why I am saying these two are loins and these two are doggies? These two are loins, loin. These two are dogs. Ask me why. Kids, always whenever tough question is there, play with the divide and rule. Always go divide and rule. See, these are phenol. Phenol's pKa value is approximately 10 and benzoic acid's pKa value is approximately 4. There is huge difference. There is difference of at least 6 pKa value. 6 pKa value. Now see, the answer will be from these two. It is applying minus I, so it is withdrawing electron and negative charge is getting decreased. So stability is getting increased. So acidic strength will increase. And this is applying plus I. It is at meta, so no ortho, so charge is getting increased, so stability is getting decreased, so acidic strength is also getting decreased. Now in phenol, no ortho effect. First of all, no ortho effect in phenol. No ortho effect. It is applying minus I, so charge is getting decreased. Charge is getting decreased, so acidic strength is getting increased. So these two will be more acidic first of all than these two, and that's why you missed it. You have not done the rule, divide and rule, that's why you missed it, kids. Got it? Everyone got it, kids? Everyone got it? Yeah, Thamil, your answer was also correct. I have given justice to you. I was unable to see. Your answer is also correct. Now, see, kids, third application, basic strength. Basic strength. Are you ready, kids? Basic strength. Now remember one thing in basic strength, always remember Baba will tell you the rule, Baba will tell you the rule. GG then LL DD then A. Now what is the meaning of this? If you remember this rule, you can do any question. If you remember this rule, you can do any question. What is the meaning of this? Just see. First, let me make sorry kids. Oh my God. Too much amount of water has eliminated out. God has given lovely life. Don't drink alcohol. Wow, Sahana. God has given lovely life. Don't drink alcohol. Now see, Sahana knows. God has given lovely life. Don't drink alcohol. Okay, God has given lovely life. Don't drink alcohol. Everyone got it? No, Kiran ji abhi nahi. After class I will do dinner. ये क्लास सुबह तक नहीं चलेगी. थर्ड एप्लीकेशन है कार्बोकेटाइन कार्बन एंड फ्री रेडिकल, दैट्स ऑल. Yes kids, I am teaching without AC. Now God has given lovely life. This trick is okay kids? Sorry. Trick is awesome or not? Trick is Arpudham, awesome, must or not? Kid is Romba Sulbham means very, very good. This is the order of basic strength. Now what is the meaning of this kids? Let's see the meaning of this. How many of you want to know? Oh my God, see, vampire is saying alcohol is bad thing. Let's end it this by, oh my God, you are really great. Now see kids, what is the meaning of this? 1G stands for, this G is for guanidine. How it will look like? C double bond NH, NH2, NH2. This is highly basic, it's highly basic. Why it is basic? When it is going to accept proton, this is delocalized, this lone pair is delocalized, but it is attached with double bond as well as, so it is localized. So the proton will attack over here. Now it will get converted to this form. Now see, this is the conjugate acid of that base. This is the base, and this is the conjugate acid kids, conjugate acid of that base. And remember that basic strength is directly proportional to what? Basic strength of base directly proportional to stability of conjugate acid. Stability of what? Remember this point, kids. This point holds a whole lot of weightage. Very, very important point, kids. Basic strength of base is directly proportional to stability of conjugate acid. Just like acidic strength of acid is directly proportional to stability of conjugate base, like that, basic strength of base is directly proportional to stability of conjugate acid, kids. Am I right? Now see, this is NH2, this is NH2, this is NH2, all three are NH2, and that is giving us a clear hint of what? That it will form three equivalent resonating structures, three equivalent resonating structures. It is going to form three equivalent resonating structures, and three equivalent resonating structure which will provide maximum stability. My dear students, mark my this word categorically. I am telling you this particular point, always keep in your hippocampus. That's why this is most basic nitrogenous base, organic base in the whole world. Most basic organic base, kids, organic nitrogen base. Kids, this point means a lot, and if you see your biomolecules, amino acid, arginine is most basic. Out of 22 amino acids, there are only 3 basic amino acids: arginine, lysine, histidine, and out of these 3, arginine is most basic, and this is responsible for making arginine to be most basic. Your amino acid arginine contains this base, and that's why arginine is being most basic. You got it, kids? Everyone got it? Kids, everyone got it? The class was started at 7:30, Ania. Kids, let me tell you, number of times it happens in the starting, kids, whenever they see, oh, this Baba, her hairstyle is not good. I never comb my hair, kids. A number of students, they come to YouTube, they will see your hairstyle, and then they will go away. Only the legends, the kids, those who are going to get rank, they can understand Baba has given number of ranks. Baba has been teaching for the last 26 years, but I never say, nowadays you see, in the starting I never say I'm having MTech, I'm having MSc degree. I have been teaching for the last 26 years. I have produced ranks. I never say all these things. Kids, Baba don't care. What do you think? Baba only knows one thing. I have to give pure teaching, pure content, so that you should get selected. Baba believes in selection. Kids, that's why you see, Baba is always teaching, never care for anything. I will give you the rank, kids. Baba can give you the rank, and tell this point to everyone, kids. Now, 1G is for this. 1G stands for this. 1G. You are my army. Jyoti Jain, Rajeshwari, Ganeshkara, Nitesh, Varan. Tell everyone, kids, my focus is to give best teaching to most of the students, so that they should get selection without paying even a single penny, kids. Baba is taking special classes all the time. Now kids, see, another G, 1G I have told you. 1G is for guanidine. Another G is for guanidine type. Guanidine type. Now what is guanidine type? If you see guanidine was like this. Now let's see, guanidine type is like this. R can be any group. Now GG I have told you. Now Baba is going to tell you. God has given lovely life. LL. Baba is going to tell you LL. LL stands for localized pi electrons. Localized pi electrons. Now this means localized pi electrons. That also means localized pi electrons, kids. Now what is the difference? Both means localized pi electrons. Kids, only the difference is the adjacent carbon is different. Here the adjacent carbon are sp3 hybridized. sp3 hybridized. And here adjacent carbons are sp2 hybridized. sp2 or sp hybridized. This is the only difference. Now let me tell you with the examples. I know that you should need examples of these two. Do you need, kids? Kids, do you need? And those who are new, kids, smash the like button, hit the like button, kids. I want to see at least make it 125, kids. Say, kids, make it 125. I want to see at least 125, kids. Now let me tell you, localized, if I say this one is localized, why this one is localized? You see, in between this lone pair and this is sp3 hybridized carbon. sp3 hybridized carbon. And if I write down like this, this lone pair is also localized. That is localized. This is also localized, kids. But what is the difference? Find out the difference. Till that time, I will write down their names, because names are very, very important. Its name is benzylamine. Everyone say benzylamine. Its name is pyridine. 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 Remember that, pyridine. One more is there, piperidine. If I write piperidine, then this is piperidine. This is piperidine. Now, kids, here the adjacent carbons are sp2 hybridized. Although the lone pair of nitrogen is localized, but adjacent carbon are sp2 hybridized. In Hindi I will say padosi carbon sp2 hybridized hai, padosi carbon. But here this is sp3. So these two will be more basic than that one. The basic strength order will be like this, kids. The basic strength order will be like this. Right, kids? Everyone got it? Now, till now, Baba HSP has told you, God has given lovely life. Don't drink alcohol. Now, Baba will tell you, don't drink alcohol. Yes, resonance show karega. But in pyridine, lone pair will not take part in resonance. I have told you this thing in the starting, because nitrogen is having, this nitrogen is having double bond as well as lone pair. So this is localized, will not participate in resonance. Will not participate in resonance. This thing I told you, pi bond conjugation is best. This resonance will take place. Are you getting my point? This will be the center of attraction of resonance. Is it clear? Is it clear, kids? Wow, Sheshadri, thank you. Kids, see, Sheshadri is there. Just see what Sheshadri has written. Really, I am telling, trust me, see all his lectures, you shall get full marks in organic. See. Wow, thank you from the internal core of my heart, Sheshadri. Kids, thank you for giving this much of respect to your Baba HSP. Really, kids. Now, till now, I have told you, I have told you, God has given lovely life, I have told you. Now, what I am supposed to tell you, don't drink alcohol, DDA. DDA. Now, what is the meaning of this DD? D means delocalized, delocalized. Now, what is the meaning of delocalized and delocalized? How they are different? This is slightly delocalized and this is highly delocalized. Now, sir, give some example of these. Let me give you examples. Slightly delocalized is aniline. Highly delocalized is pyrrole. Now, kids, what are their names? Its name is aniline. Its name is pyrrole. Now, just find out why I have written slightly delocalized and why I have written highly delocalized. Wow, see Sahana, what Sahana has written, that full chemistry they are following from Baba. Wow, billionaire, what billionaire has written, सुबह आपकी कोचिंग के टीचर्स के, oh my God, right. Now see, kids, this benzene is saying, I am aromatic, I don't need help of your lone pair, I don't require your lone pair. So it's saying, I need you right now. But here, this ring says, we are incomplete without your lone pair. If their lone pair is not available, we won't be aromatic. So this is very much required for completing their aromaticity. That's why it is highly delocalized. Got it, kids? Now A for amide. Amides are least basic because the attack of proton will be on oxygen, because this is delocalized. This lone pair is delocalized and this is localized. So they will be at the last. This is all about basic. Now, carbocation. I will write down the full order of carbocation. Carbanion, free radical. That's it. It will need only 15 to 20 minutes. Now tell me kids, are you ready to give me your 15 to 20 minutes kids? Just 15 to 20 minutes, nothing more that. Jyoti Jain is saying, sir, such बहुत बढ़िया पढ़ाए हैं. Sure, whether you are JEE or NEET students, you will get full marks. See kids, how much respect people are giving to your Baba. Now, next application. Stability of carbocation, right kids? Are you ready? Baba will write down the order. Stability of, this is fourth application. Stability of carbocation. If you are ready to give me your 20 to 25 minutes, then show me green hearts or fire. Of course, why not? People are writing, of course, why not? Oh my God, billionaire is writing, Baba can teach MIT students. Thank you, thank you, thank you. Thank you so much. Now see, first line I will say, the most stable are the one which shows dancing resonance. First line one are dancing resonance one. The one who shows dancing resonance. Dancing resonance. How the compound will show dancing resonance? Just see, if they are attached with cyclopropyl ring, 3 cyclopropyl ring, maximum dancing resonance. Then I will say 2 cyclopropyl rings, less dancing resonance. Then I will say only 1 cyclopropyl ring, least dancing resonance. But wherever you see the dancing resonance is happening kids, remember that this type of compound, they will always be maximum super awesome dawesome, they will be maximum stable. They will show first line of stability. Oh my God, gets very good. Always remember that. What is required for dancing resonance? Carbon plus and at least 1 cyclopropyl ring. At least 1 cyclopropyl ring. It is not possible in any other rings. It is just possible in cyclopropyl ring. Remember that. No other ring will show dancing resonance, because in cyclopropyl ring, this bond is banana bond. In between sigma and pi bond. In between sigma and pi bond, and that's why it will show dancing resonance. This is the first liner kids. Will you remember it? After this, Baba is going to tell you about B, C and like that. Everyone ready kids? Oh dear Ames, well my God, billionaire thinking is dear Ames. Everyone, huge round of applause. Our dear Ames has come. Hey, let me drink some water. Let me have some water, kids. Dear Ames is there. Hey, welcome, welcome. Warm welcome to dear Ames. Wow. Dear Ames is there, kids. Huge round of applause for dear Ames kids. Huge round of applause. Now see kids, second liner. Now dear Ames, you must have seen Yeah, it's even you can get full marks if you start right now. Now kids and dear aims, you must have seen number of pupils class. Now you can compare the content. Dear aims, let me know. You must have seen number of pupils class. Now just compare this class. I want the true rating. I want to see the true rating, dear aims. Now B point is tropylium cation. How it will look like? Tropylium is yellow crystalline solid. Remember that. Its name is tropylium cation. Kids, we say that these carbocations, we cannot sell them, we cannot purchase them, we cannot see them because they are highly unstable and they exist only within the solution. But this carbocation is that much stable that it exists as yellow crystalline solid. This exists as yellow crystalline solid. It's exist as how kids exist as yellow crystalline solid. Now kids, who is making and what factor is making is this tropylium cation to be that much stable? That is the $1 million question. Now see kids, 1, 2, 3, 4, 5, 6 planar as well as following Huckel's rule, 6 pi electrons, and this is aromatic. One thing, there are number of compounds which are aromatic, but what's special over here? It is having 7 equivalent resonating structures. Kids, that is special. That it is having 7 equivalent resonating structures. 7 equivalent resonating structures. That is the most important point. This is very, very special about him, that the positive charge will move on all the carbon atoms. That is very, very special thing. Now, this is, now after this there is one compound. You see the color and try to find out which compound Baba will draw with red color. Can you see? Is it visible? Hey, is it visible? Kids, do let me know. Is it visible? Yes, sir. It's visible. Now, it will show 10 resonating structures. How, kids? Right now, the positive charge is on this carbon. Then it will come over here. Then it will come over here. Then it will come over here. OP, OP, OP. Oh my OP, 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 9 and 1 itself, 10 resonating structures. But kids, but then also who is winner? It is forming 10 resonating structure, it is forming just 7 resonating structure. But then also who is winner? Who is winner, kids? Who is winner? Who is winner? The 7-1 or the 10-1? Tell me, who is winner? 7-1 is winner because 7-1 is having equivalent resonating structures and it is having non-equivalent resonating structures. Non-equivalent Now kids, what is the meaning of non-equivalent resonating structures? What is the meaning, kids? The meaning is that if you have seen one movie, Jeevan, there was one hero, Shah Rukh, there was Ravan. He was beating him like, but at the last he was getting frustrated, hero was getting frustrated. He has fallen down, then his child was saying, Papa, shadow, shadow. One of its mirror image got shadow. Villains, out of 10 images or 12 images, I don't know, yeah, 10 images, Ravan, 10 images, one was forming shadow, and then he recognized this is the actual one. If all the images, they would not having mirror images or the shadow, then definitely the hero would not be able to find out which is the actual one, right? Now kids, this is more stable, this is less stable. This is the B point. Now let me come to the C point. C point. Carbon with 3 phenyls. I have written 3 phenyls. I can write pH in place of phenyl. Can I write? pH means, let me write down over here, pH means what? Meaning of pH is what? pH is phenyl, Me is methyl, Et is ethyl, right? So 3 pH, carbon with 2 pH, 1 Me, carbon with 2 pH, 1 hydrogen. After this, carbon with 1 pH, 1 methyl. After this, carbon with 1 pH. Now kids, at this point I will tell you one thing. If you are preparing for IIT and if you are preparing for NEET, then you have to keep one thing in your brain, kids. You have to think for this. Out of these two, let me tell you kids, out of these two, this is benzyl, this is tertiary butyl, now kids, for IIT this is more stable. Sir, what are you talking about? Kids, yes. If you are preparing for IIT, then this is more stable. This is for IIT, I am telling you. And if you are preparing for NEET, then this is more stable. So what do you mean by this? Yes, am I right or not, kids? Definitely I am absolutely correct. Because they have almost same stability, but if you are preparing for NEET, then this will be your answer. If you are preparing for IIT, then that is going to be answer. Thank you, Kiran Pathak. Thank you, Sahana. Now kids, this point is clear. If this point is clear, then let me write down allyl. Now kids, remember one thing. Let me tell you one thing. Allyl will form 2 equivalent resonating structure when also benzyl is more stable. Even though this is forming 2 equivalent resonating structures. But then also this is winner. Remember that. Not only. Now let me tell you what reasons are responsible for all this. But let me complete it, then I will tell you. So this is C. Now Baba is going to come to D. Let me complete first. Allyl. This is the allyl carbocation, kids. After this, isopropyl. 6 alpha hydrogen atoms. After this, ethyl. Now, once I am writing ethyl, after ethyl, CD3, CT3. Now, here hyperconjugation is more dominating than plus I. H dominates over plus I, but at the same time, just see, in this compound there is no hyperconjugation, so tritium will be winner. Just see to it, kids. Now see, these three compounds are not having alpha hydrogen, so it's inductive effect, isotopic effect. Now kids, some factors are responsible for giving this much order. Baba is going to tell you. Are you ready, kids? Let me tell you. Now see, kids, who is responsible for stability of carbocation depends on the following factors. Just see what are they. Factors responsible for carbocation stability order. Remember, dare his. What I am telling you? Dare his. What do you have to remember, kids? Day Baba Rahis. Day Baba Rahis. What is this? Day Baba Rahis. What is the meaning of this? Yeah, in Hindi, if you know Hindi, Day Bibi Rahis. In English, Day Baba Rahis. RHS. Dare Bibi. Now see, kids, what is this? DAEBBRHIS. Remember that. Now, number of kids, they are doing mistake at this place, Rahis. So remember, this Rahis is very, very important. Very, very important, kids. Let's see. What is this? D for dancing resonance. Say dancing resonance. Dancing resonance will play maximum role. A for aromaticity. Aromaticity. E for equivalent resonating structures. Equivalent resonating structures. BB for back bonding. Never forget BB or Baba or back bonding. Never ever forget back bonding, and during the examination you will forget about back bonding, so don't forget back bonding will play maximum role. Now R for resonance. H for hypoconjugation. I for inductive effect. S for percentage of S character. Now 1, 2, 3, 4, 5, 6, 7, 8. Now if they are getting failed, if anywhere they are getting failed, then there are two more factors which are experimentally determined. Two factors experimentally determined. Solvation and field effect. We cannot determine these two effects theoretically. They are determined experimentally, and that's why we have to cram that order. Always don't apply your brain. Always brain will not work. Sometimes brain will get failed. So remember to apply whatever Baba has told you, kids. H for Harin Singh Parhar. Yes. Now kids got it. You can take screenshot if you want. Always remember they Bibi, they Baba Rahis. They Baba Rahis. They Baba Rahis. Got it, kids? Now, let me give you one question based on this. Kids, are you ready? 10 more minutes, 10 more minutes, just 10 more minutes, kids. Then the class will get over, right? Kids, right? Now, let me give you one question based on this. Till now they are same. Till now they are same. Okay. Can you see? Is it visible, kids? Is it visible to all of you? Now tell me. This is a real question. Let's see who is going to give the correct answer, kids. Baba is waiting for your answer, kids. Billionaire has given 3124. Do you want to change your answer, dear Ames? Would you like to change your answer? Beta, haan, Kiran, I will eat. Thank you for taking care, kids. After completing it, then I will eat comfortably. If I am going to leave in between, Baba won't be able to sleep. So, I want to give you the clear concept, full concept, then only Baba is going to eat. Now, see, kids. This is donating electron through plus M. That is plus R. So, the electron will come over here and this will decrease the charge. Suppose if I say the charge decrease like this much. Let me write down charge decrease 50 much. Okay. Same charge will get decreased over here because it is at para. Mesomeric effect from para is same as plus ortho. So, it will come at this place and charge will decrease 50 much. This much is clear, kids. In ortho and para, resonance is equal. One point is clear to each and every one. Now see, kids, if I say that over here it is applying minus I also, so due to minus I charge, because it is withdrawing electron, charge will increase 3 much. Now let me first of all talk about minus I. Meta only minus I works. Charge will increase too much. This, it's not of English too much. 1, 2, 3, it's chemistry too much. And here charge is increased 1 much. So 50 much decreased, increased 1 much. Overall charge decreased how much? 49 much. This 50 is arbitrarily. In place of 50 you can take 10, 100, whatever you want, because it is more than inductive effect, right? Now here this much increase, so charge increased 3 much, decreased 50 much. So overall its account is charge decreased 47 much. Am I right till now? And here just charge decreased or increase too much. This is final, okay? This one is final. Are you getting my point? Why I am saying it is final, kids? This is the final chart. This is the final chart. And this is having whatever it's having charge. So who is having least charge? Tell me who is having least charge. Definitely this is having 49 much decrease. So this is most stable. So C is most stable. After C, A. Now till C and A, Dr. Ames, you were correct. Till now it was correct. Jivan, Shakti, till now it was correct of Dr. Ames, but after that D will come. Here you missed, dear Ames. After that C will come. You missed at D and C. Am I right or not? Kids, you got it. Everyone got it or not? Just do let me know, kids. Is this point clear to each and every one or not? Do let me know, kids. Ratan Sethi is saying for CADV. No, this is correct. Tell me, kids, everyone got it or not? Then I will give you one more question. Then Baba will give you one more question. But first of all, do let me know, everyone got it or not? It's clear to all of you or not? C is most stable, then A, then D, and then, oh, 2 times C has come. Kids, 2 times C has come. At last, what will come? CAD, B will be at the last, B. It should be like this, kids. Right, kids? You got it or not? Everyone got it or not? First of all, do let me know. Is it clear to each and everyone? Yeah, there is only one option with minus I only, no plus M, no plus M. Now, if this same question has been given for NO2, if the same question has been given for NO2, just see. If I give you the same question for NO2, just take care, kids, this time. Be aware of it. This time I want clear-cut answer, kids. Now tell me, kids, let's see who is going to give correct answer. Yes, let's see. Oh, dear, I am so quick. DBAC, B, A, C. Dear Ames, once again, yeah, Thamil is correct. Thamil is correct. Okay, you changed billionaire, now you are also correct. You are also correct. Now see, who is not having minus I and minus M? This one. So this will be at the top. Who is having only minus I? Only minus I. So only minus I, it will withdraw electron. So I would like to say charge increased too much. Let's see the accountancy of minus I. Charge increased too much. Charge increased 1 much. Due to minus I, charge increased 3 much. Right, kids? Due to minus I, these are the charge increased. Minus I charge increased. Now see, here minus M effect is 0, not applicable. But here minus M is charge increased 50 much. Here minus M charge increased 50 much. Now just see, in this the account will be charge increased 53 much. Now here only 2 much. Here charge increased 51 much. Now who is having least charge? Tell me who is having least charge. D, after D, after D, B, after B, 53, C, D, B, C, A. Right, kids? You got it? How many of you are able to understand and how many of you are enjoying it? Another question. Now, kids, another question you want? Now, I will give this time another question based on you. How many of you want? How many of you need, kids? Do let me know. Next question. Oh my God, everyone is enjoying. See then. Do let me know, kids. Okay, everyone is in need of question, kids. That's really fantastic. Chandan Kumar also saying, so Billionaire is going for CABD. CABD. And Thamil is going for ACBD. Siddharth is going for ABCD. Oh my God, number of students with different answers. Let's see. Let's see first of all for plus I. Plus I nearest. So through plus I charge decrease 3 much because it is nearest. Through plus I charge decrease 2 much. Through plus I charge decrease 1 much. This is 1 much, 2 much is nothing. I am comparing it that like this. Now see, if I say about mesomeric effect, hyperconjugation through plus H charge decrease 10 much. So same here through plus H charge decrease 10 much. Why I am saying 10 much? Because resonance was more affecting, that's 50. So it is 10 only. No plus H is not applicable, so 0. Let's do the account clear. Here total overall charge due to high hyperconjugation and inductive effect charge decrease 13 much. Charge decrease 13 much. Here charge decrease 2 much only. Here charge decrease 11 much. So where charge maximum? A. So the answer will come out A, then C, then B, then D. How many of you got the correct answer? Show me green hearts if your answer is matching with my answer, otherwise fire. Otherwise fire. If your answer is getting matched with my answer, then green hearts, otherwise fire, kids. Otherwise fire. I want to see fire and green hearts. If you are able to understand, do let me know, kids. If you are able to understand, do let me know, kids. Siddharth, I have explained. See, kids, I have explained, because from here hyperconjugation will not work. From meta hyperconjugation will not work. Hyperconjugation will work only from ortho and para. Now, last question, then I will go with carbanion. Okay, in this category, last question. CMe3. On carbon there are 3 methyls, right? Yes, yes. Ratan Sethi, carbanion and free radical. Yes. Kids, do you think Baba is the only one who is framing out questions on the spot? Do you think Baba is the only one who is framing out questions on the spot? Baba never brings questions. Oh, thank you, Sahana. Thank you, Billionaire. Thank you, Chandan Kumar. Really, my God, kids, you're rocking, rocking. Kids, you're rocking. You made my life. You made my day, kids. You made my day, 15th of August. Really, kids, super awesome, blossom. ACBD, ACBD, everyone is going. DBC, oh my God. Different answers. Okay, let's see. CMe3 means no alpha hydrogen. CMe3 is like this. Do you think there is any alpha hydrogen? There is no alpha hydrogen atom, right? So only plus I, only plus I. Now plus I works maximum from this distance, ortho. Inductive effect is maximum at ortho, then meta, then para. I told you this in the starting lecture of that. So A, B, C, D, that's it. A, B, C, D. You got your mistake. When there is no alpha hydrogen, then this is going to be the order. This will be the order. Got it, kids? Everyone got it? Thank you, Kiran. Thank you. Now I am going to move towards the fifth application, that is carbanion, then free radical. Everyone got it? Now see, kids. Next application is stability of carbanion. First I told you aromatic, anti-aromatic, then acidic, basic, strength, carbocation, fifth. Carbanion stability. Factors on which it depends. ARBBSI. What is that? ARBBSI. What is the meaning of this, kids? ARBBSI, what is mean, kids? A for aromaticity, R for resonance, BB for back bonding, S for percentage of S character, I for inductive effect. Now, after knowing all these things, should I move towards question? The same question, but this time benzyl carbanion. Are you ready? Same with. Now, question is, stability order you have to define for this. Same thing, but this time you are having negative charge. Just take care. OCS3, I will start with same thing. Take care this time. Try to give the correct answer, kids, and remember this charge. This time there is negative charge. Earlier it was positive charge. It's a challenge, kids. Let's see who is going to win this race. I don't want to see different type of answers. I want to see only one type of answer from each and every one of you, kids. Let's see who is going to give the correct answer, kids. Everyone. Sahana is going for BDAC. 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 Hey, claps. Sahana, absolutely correct. Question is, oh my god, I have not written decreasing order of stability. Sorry, Ratan Sethi. Decreasing order of stability. That's my bad. I was increasing, decreasing. You are right, Ratan Sethi, you are right, absolutely right. Thamil, your answer is also correct, but it's my bad that I was not able to write there that decreasing order of stability, kids. That was the most important point. Now see, kids, this will work minus I only from here, because here minus I as well as plus MR is working, minus I as well as plus MR is working. So definitely this is going to be more stable. After B, there is no resonance working. So D. Once B and D is clear, half of the work has been done. So it will apply more minus I because MR is same. MR is same in both A and D. A and C, sorry. A and C, MR is same. Oh, MR is same in both A and C. So, A, then C. Everyone got it, kids? Do let me know. Is it clear to each and everyone or not? This is clear. Thank you, Kiran. Thank you. Now got it? Should I give you another one? Should I give you another one? Should I give you another one, kids? Should I give you another one, kids? Do let me know. Now see. Same, decreasing order of stability. Kids, decreasing order of stability, same question. Let's move here, let's move here. Yes, Ratan Sethi, you are right, absolutely right. Decreasing order of stability, once again, decreasing order of stability. A, C, B, D. Sahana is going for A, C, B, D. And Thamil is also going for A, C, B, D. Let me check. A, C, B, D. A, C, B, D. Oh my God, absolutely correct. You have become genius, kids, everyone. Now, though, you are rocking, kids. No need of teacher now. You have become genius, kids. Now, though, you people have become genius, kids. Now, you don't require any teacher, kids. Now, you can do any question, kids. Now, I am sure, pretty sure that you can do any question. No problem. You kids are rocking. Now, last application. Stability of free radical, right? Now, free radical, I will say, is a point of very much discussion. There are 2 points. Let me tell you first of all, captodative effect, not required for NEET but required for JEE. Captodative effect. This I will tell you because not required for NEET. So, for JEE students advanced, I will tell you later on. Captodative effect, there is push-pull mechanism. Push-pull mechanism is there. So, that is the point of much discussion, but I will tell you kids this thing in detail whenever it is required, only for JEE students, advanced students. Otherwise, one more factor is there, steric factor. If I leave these 2 points, then only A, R, H. Aromaticity, resonance, hyperconjugation inductive effect. Now, see kids, by keeping all these points in our brain, I will say the most stable is this compound. Always remember that. Its shape is propeller shaped, remember that. Its shape is propeller shaped and it is highly stable because of too much steric hindrance. Now, how many things are there? It is aromatic, first point. Aromaticity, so resonance will be definitely there. Now too much steric hindrance is there, too much steric hindrance. Now why I am saying this too much steric hindrance kids? Have you ever seen that jar having 3 plates? Mixie jar, propeller jar, fruit mixer. Have you ever seen fruit mixer, or I can say your fan of cooler, the fan which is there in cooler. So it is too much sterically hindered that on one carbon it can accommodate there is very tough, one benzene, one phenyl is getting slided over another phenyl, means one fan is slightly tilted over another fan, like this plates are slightly tilted kids, and that's why this is highly stable. After this, I would like to say carbon, then 2 phenyl and 1 methyl, because there will be hyperconjugation also. After this, 2 phenyl only kids. Now, my dear students, point to be noted over here, what I am going to tell you, that means a lot. After this line of stability, I would like to tell you something kids. After this line of stability, it will go like this, it will end over here, right? Now, I would like to say allyl is more stable, allyl free radical is more stable, only very less difference is there, although very less difference. Allyl is more stable than benzyl, remember that, if they are going to ask this question. In both the cation and carbanion, benzyl was more stable than allyl, but here it is a winner. Allyl is more stable than benzyl, remember that. Remember this point to be noted, my dear students. After this, tertiary butyl. Now tertiary butyl is at the last over here. Then isopropyl kits. Then here ethyl, methyl, and so on. It's like this kids. It's my choice. It's my choice. Now completed kids. Shubh Ratri, Shabba Khair. Bye bye. Good night to all of you kids. So this is all. Kids, Baba is really feeling awesome. Baba is feeling fully accomplished because finally you have given the best answers, kids. PDF milega, Kiran. PDF I will share, don't worry. Kids, really you made my day. I would like to say thanks to each and every one of you kids for giving so great answers. How was the lecture? At the last of the lecture, once this video is off, you have to comment over there. I want to see your comments. Then I will give you more questions like this. Yeah, Sahana, Kiran, Jeevan, Jyoti. Thanks kids. Bye to all of you. God bless you. Love you kids. Bye bye. Bye bye kids. Bye. Thank you Jeevan, Jyoti, Jain. Oh my God. Yeah, Chandini Kumar. Thank you. Really thanks. Bye. Good night. Shubh Ratri, Shabba Khair. All the best kids. God bless you. Love you kids. Ratan Sethi. Bye. Thamil. Bye. Kids, don't forget to share this video so that everyone can get the benefit, kids. I remember number of people are there, those who are unable to join the batches. Number of problems are there, number of sufferings are there, kids. So don't ever forget to share it. Will you share? Put more comments once the video is over, kids, because whatever you liked, other students will see the comments, then they will decide. Because I am a very common person, no hairstyle, no other style, nothing Baba will do for increasing views. Only I can give the quality content, kids, so that everyone can get helped, everyone can get the best rank. Bye to all of you, kids. God bless you. Love you, kids.